Welcome back, students. We're going to continue solving systems of equations, and today we're going to learn the third way to solve systems of equations, and it's called elimination. Day one, ignore that. I put day one and day two together just so we can get through it. I think we'll be fine. But our objectives are that you'll be able to solve systems by adding or subtracting, and first multiply when solving multiply first when solving systems. We'll talk about that. And you'll be able to define the elimination method. Okay, before we learn the elimination method, I want to show you why it works. Okay, so when we're solving an equation, don't read this right now. Let's just look here. When we're solving an equation, we do the railroad tracks. Sometimes we add 1 to both sides, and it works because we're adding the same value to each side, right? We're keeping it balanced. So if we have an equation x minus 2y equals negative 19, watch what we're going to do here. It says if 5x plus 2y equals 1, that means that 5x plus 2y and 1 have the same value. In other words, 5x plus 2y equals 1 and 1 equals 1. So they're both worth 1. So you can add 5x plus 2y to this side, and you could add 1 to this side, and it would stay balanced. I know it's obscure, I know it's kind of weird, but it's okay to do. So just remember this. Just remember this. Here are some steps to remember. When we solve systems of equations, first is we write this system so that the like terms are aligned. I'll show you how to do that. Then we try to eliminate one of the variables and solve for the other variable. And from here on out, it's kind of like substitution. Once we get the value of that variable, we'll substitute it into the original and find the other, and then we always end by writing our answer as an ordered pair, because remember, systems of equations is talking about where two lines meet on a graph. So all we're trying to find is where do the two lines touch each other. Okay, hey, here's our first problem that we're going to solve by using elimination. So, first thing we do, first of all, I want to start by saying this. My students, when I teach elimination, I want you to always add. I'm not going to bend on that. I want you to always add, and I'll talk more about that later. So anyway, if we look here, we notice that there's a positive 3x and a negative 3x, and if I were to add each term going down, so I add this to this, this to this, this to this, the like terms are lined up. If I were to add, these two x's are going to disappear. Watch. So 1y plus 2y is 3y, and then 3x plus negative 3x is 0x, and you do not have to write this. I'm just doing it the first time to show you. And then negative 2 plus 14 is 12. Well, this cancels, or this is just nothing, so we cross it off. Now we're left with 3y equals 12. Pretty easy from here on out. So we're going to divide both sides by 3, and we get y equals 4. Remember, our answer is an ordered pair, so I'm going to write 4 in the spot of the y. Now, just like last time, with substitution, I need to take that 4 and put it back into one of the equations. So I'm going to put it into the top equation. Okay, so here's the top equation. I wrote it here, y plus 3x equals negative 2. I'm going to substitute the 4 in. I accidentally wrote negative 4. Let's make that positive, sorry. So take the 4 and we're going to substitute it in for the y. And let's solve this. So how do I get rid of this positive 4? I am going to minus 4 from both sides. And when I do that, this becomes negative 6. And then we have 3x equals negative 6. So we know that we divide both sides by 3, so x equals negative 2. X equals negative 2. And notice I wrote it in my ordered pair, so here's my answer. My answer is negative 2, 4. I could plug it in and check. It's going to work. If you were to graph these two lines, they would touch at -2, 4. Another systems of equation that we're going to solve with elimination. So again, make sure your x's are underneath your x's and your y's are under your y's and your constants are under your constants. And then see if you are ready to go. And I am ready to go because -4y plus +4y is going to be 0. So we always add. We always add. So 3x plus 1x is 4x. Then I'm just going to cross these off and not even write 0. I'm just going to cross them off because they cancel. 10 plus -2 is 8. Watch how easy this is. We divide both sides by 4. X equals 2. That was quick. So we know that x is 2, so we're going to write it right there. Now we just have to go back. So this time I chose to use the second equation just because the x was by itself and I thought it might be easier. Either equation will work. So I took the 2 and I put it where the x is. So 2 plus 4y equals -2. I'm going to minus 2 from both sides, and when I do that, this will cancel, and then I'll get 4y equals -4. So I kind of know what the answer is already, but I'll show my work. I'm going to divide both sides by 4, and I get y equals -1. So I'm going to go back and put the -1 in where y is. I'm done. That is how you solve with elimination. Okay, first of all, on this slide, would you please cross off, go like this to the question on the bottom of the slide. Would you cross it off, please? Do that, and just we're skipping that one. We're just going to do this one. So, elimination, make sure your variables are lined up. X, X, Y, Y, constant, constant. Great. Okay, one problem. 2x plus +2x is 4x. It's not 0. So, and I make you add. I will not allow you to subtract. It's not allowed. Not in my room. So, what we're going to do is you need to multiply the bottom or the top equation by -1. So I'm going to multiply the bottom equation by -1 so that I can add. So watch what happens. When I do that, this becomes negative, this becomes plus, positive, and the 13 becomes negative. Okay, please do that on your paper. Now I am able to add because I multiplied by -1. I can add. So -2x and +2x, that's 0, so that cancels. Great. 1y, now it's plus 5y is 6y. Then I have -5 plus -13, that's -18. Again, if this works, it's easy. If it works, it's easy. So you cross this off, y equals -3. We write our answer, and we know that it's y, so we write it second. Now we're going to pick one of our original equations. Please pick one of the originals. Don't pick the one you changed. It shouldn't make a difference, but to be safe, I always pick one of the originals. I chose the top equation this time. So 2x plus y equals -5. So I'm going to take this -3 and I'm going to put it right here. And then I'm going to finish my equation and I'm going to solve this. So how do I get rid of that -3? I'm going to add 3, and when I add 3 to -5, I get -2, and then I get 2x on this side. So my answer is going to be -1. You probably already thought that. So x equals -1. Remember, always write it as an ordered pair, and you're done. These two lines touch at -1, -3. This is an important example that I want to make sure I show you. In this example for solving by elimination, you'll notice that the variables are lined up, and that's great. The like terms are, but 2 and 3 are different, negative 5 and 2 are different. So when this happens, it's kind of like fractions of making a common denominator. You need to make both of the x's the same number with opposite signs, or both of the y's the same number. So I could make these both 6, except they're both positive, or I could make this negative 10 and this positive 10. And that is what I'm going to do. I want the top number to be negative 10x, and I want the second equation to be positive 10x. And I'll show you what I'll do. To make this turn into this, I'm going to multiply everything on top by 2. So I'm going to multiply this by 2, this by 2, and this by 2. And here's what I end up with. Obviously I get negative 10x, then I get plus 4y, and then I get 64. Now I'm going to multiply everything down here by 5 so that I get 10x. I'll multiply 2x by 5 and get 10x. Then I'll multiply this by 5 and this by 5. So 5 multiplied to 3y is 15y. 5 multiplied to 10 is 50. We're ready. We're ready to go. So always add. So let's add. Negative 10x plus positive 10x, that cancels to 0. Great. Then 4y plus 15y is 19y. And then 64 plus 50, that is 114. So now let's divide both sides by 19. And y equals 6. All right. Doing that ordered pair thing again. And now we have to pick one of our equations to take the 6. Take the 6 and plug it into. I chose the bottom equation this time, and 2x plus 3y looks like this. 2x plus 3 times 6, because 6 is y, equals 10. Notice I did not use the red or blue equation. Technically you could, but it's safer to use the original. Okay, let's solve that. So x equals negative 4. X equals negative 4. And there's our ordered pair. And once again, remember, this point is where both lines intersect. This slide is just another reminder of the steps we take. And if I were to add anything to this, I would just say always add, never subtract. Okay, you have some practice problems. Please do those and make sure you bring any questions you have to class. I do want to say one thing. One type of problem I did not show you or let you explore in this video was what happens when x is on this side and on this equation x is on the other side. So we can talk about that in class. Basically what you need to do, and I did not put this in the video, I wanted to keep it short, but what you need to do if x or y is on the right side and on the other equation they're on the left, you have to move them over there so that they look and line up the same. So y on top of y, x on top of x, constant on top of constant. That's it. So I'll bring you to the next slide here. Okay, here's the next slide. Make sure you show all work and bring those questions to class next time we meet. Take care.